Okay, so as an introduction to group theory, we're going to go over a basic idea. So if we have some group, let's say G1, with three elements, right? Say A, B, and I don't know, let's say actually C to make it interesting. And we have another group, G2, I don't know, let's say alpha, beta, and gamma, right? And we know that these are both groups, then they're actually really structurally, according to group theory, the same group. So there's no real distinguishing between these two, and that they're isomorphic, which sort of just means same shape. Okay, from Greek. But yeah, they're going to be the same. And you can prove this. So what do you need? We know G1 is a group, so we know that there's an identity element. And let's say that C is identity here. Right? And then here, let's just say, I don't know, gamma, to make it easy, the third element is identity. And you always need that, right? Okay, you need an identity. So now let's go through maybe the multiplication table, right? So with this information, let's see what we can possibly have for G1. So let's say I have A, B, and C here, and then A, B, and C here. So this is going to be A star A, this is going to be A star B, this is going to be A star C, right? But A star C must be A, right? Because it's the identity. And then we're going to have, C star A is going to be A. And we can just sort of fill in these because this is going to be B. And then C star, this is going to be B, okay? And then we also know that every row must contain, each element in the set. So A star A now can't be A. And then A star A could be C. It could be that A is its own inverse, right? And then that would mean that A star B is B. But A star B being B would mean what? A star B equaling B would mean by the cross cancellation that A is the identity, or the right side cancellation law, right? Because we could multiply by the inverse of B on both sides, which must exist, and get that A is the identity C. Sorry, I'm using C for the identity here. So we know that this situation can't occur, actually. So I must have it that A star A is B, and that A star B is C, the identity. Right? A star B is the identity, right? And the inverse of A is B. That's the only way that this can happen. And then now we go to the next row, and again, by similar logic, let's say I had that this was, B, right? B star A is this location right here, right? B star A, let's say it's B, right? That would again imply that A is C, the identity, because you just do the inverse, and that's no good either. So we're forced to have that this is C, right? Because it can't be B, because B already appears in the row. And then now B star B must be A. And now I filled in this multiplication table. Similarly, right, I just am going to go through the same logic here, and by the same way, it forces there to be only one group, alpha, beta, gamma, right? And by the same kind of logic that I had before, right, if gamma is the identity, then you have to have alpha, beta, gamma here, and then alpha, beta, gamma going down, and then alpha star alpha must be beta, and then this must be the identity, and then so forth, and then this must be the identity, and then this one must be alpha. And if you notice that if I have a function or an isomorphism, we call it F, right, and I map A to alpha, and I map B to beta, and then I map C to gamma, what this is this just changes the names, and there's no structural difference, right, between these two groups. And this shows this function here is what we call an isomorphism, G1, and sometimes F, right? If F is a function, we say F is an isomorphism. And an isomorphism has a very particular definition that we're not going to go into right now, but it's an isomorphism. We should see that these two groups have the same exact structure. You're just changing out the names of these ideas. And this was general. This was any three elements. This is any three elements. You must have identity, and you must have inverses. So you must have it that either A star A is equal to C or A star B is equal to C in this row, right? If A star A equals identity, then what would you have a problem, right? A star A is equal to C, right? Oh, then this is C. Yeah, okay. And then A star B must be A, and that's your contradiction, because then this would imply B is C, B is the identity, and that's no good. Yeah, so basically, and it doesn't even matter, A appears in the row, you can't have it in the row, but this is why you can't have that duplicate in the row. Every row must have every element appearing once in the multiplication table for a group. But anyways, yeah, you should see that these things are exactly the same structurally, and that's why we say that G1 and G2 are isomorphic if an isomorphism exists between them. This is the isomorphism, this function, okay? It's a function, an isomorphism. And we say two groups, this group is isomorphic, the same, this group is isomorphic to this group if there exists an isomorphism between them. There could be many isomorphisms, but typically this gives you the idea.